Morning, Trig fans. How we doing this fine morning? It's sunny outside. It's a little chilly outside. It's a Tuesday morning. If you're trying to keep track of what day it is Tuesday morning. Yesterday we worked on double angles. Today we're going to work on half angles, half angle formulas. And we'll go through some derivations, how we come up with half angles, just like how we came up with the double angles. If we take a look, what I'm going to do is I'm going to let A equal 1/2 x. And yesterday, when we talked about with our double angles, we had 3 different double angle formulas for the cosine. One of them was 2 cosine squared A minus 1. What I'm going to let A equal is I'm going to let A equal 1/2 x. Now, x is going to be any angle still. Any angle we want, I'm going to let x equal. So if I take half of an angle, or if I multiply by half, I'm taking half of the angle. So this would give me my half angle ideas. If we substitute in, we have cosine of 2 times this 1/2 x is equal to 2 cosine squared of 1/2 x minus 1. Okay, what we're going to try to create is going to try to create half angles. Now we can multiply by a half, or we can also write this as 1/2 x is also x over 2. And what I'll do is I'll transform into x over 2. When I divide by 2, I give me a 1/2 x. Well, if I multiply 2 times 1/2, they go bye-bye. So we're left with cosine of just x here is equal to 2 cosine squared x over 2 minus 1. Now, if we add 1 and add 1 to both sides here, okay, we add 1 to both sides. What we are left with is a cosine of x plus 1 is equal to 2 cosine squared of 1/2 x. This is multiplication by 2. We can divide both sides by 2. So we're left with, I'm going to switch these around. Cosine squared of x over 2 is equal to cosine of x plus 1, all divided by 2. Lastly, we could take the square root of both sides. So what we're left with is a cosine of 1/2 x, is I'm going to switch these two around also. 1 plus the cosine of x divided by 2, and this is a square root. So this is your cosine of a half angle. 1 plus cosine of x, once again x is any angle we want, divided by 2. If we take a look at another one of our trig ratios trig identities that we did yesterday, the double angle for cosine 2a was also equal to 1 minus 2 sine squared of a. So if we make the same substitution, we have the cosine of 2 times this 1/2 x is equal to 1 minus 2 sine squared of this 1/2, or x over 2, 1/2 x, or x over 2. Okay, once again, if I multiply here, we're left with cosine of x is equal to 1 minus 2 sine squared of x over 2. Now, what we're going to do is one of my favorite properties of mathematics, which I've coined and trademarked as the double switcheroony. The double switcheroony. Well, we're going to take this and move it over here, and this to move it over here. The reason why I want to get this coefficient as a positive value, so I'm going to subtract cosine of x, subtract cosine of x, but then add 2 sine squared of x over 2, add 2 sine squared x over 2. So what this turns into is 2 sine squared x over 2 is equal to 1 minus cosine of x. Now it's starting to fall into what we just dealt with. We can divide by 2 by 2. So we're left with sine squared of x over 2 is equal to 1 minus cosine of x divided by 2. And then to get rid of my square, we could square root. So we have the sine of x over 2 is equal to plus or minus the square root of 1 minus cosine of x all divided by 2. And that's the sine of our half angle. And once again, you can utilize these formulas as you go through any type of quizzes or review sheets or worksheets or the extra problems I give you at the very end. You can use these formulas here. Feel free to utilize them. And if you print off the formula sheet also, these are also on those too. Now, if we take a look at the tangent of half x, and if I'm going too fast, once again, just hit your pause button. If you look at the tangent of half x, hey, we have a guest speaker again today. Say hi, Mr. McFerrin.
Hi, Mr. McFerrin. Hey, when you are done, will you stop on my room, please?
Sure can. Will do. We're almost done here. Tangent of half x. It's always great to get a cameo appearance from one of the fellow teachers here. The tangent of x over 2, half angle, can be defined to as sine of x over 2 over cosine of x over 2. So if we take a look, we have the square root of 1 minus cosine of x divided by 2 over square root of 1 plus cosine of x divided by 2. And these are both plus or minus. What happens with these things is these 2's cancel out for us, and we can combine this as plus or minus square root of 1 minus cosine of x over 1 plus cosine of x. And this is your tangent of half angle. Now, I do not recommend that you utilize that. And we'll go through 2 other alternate formulas for the tangent of half x. If we take a look at 1 minus cosine of x over 1 plus cosine of x, and we use one of our trig identities from the very first week, and we also utilize a property of fractions that we can multiply top and bottom of a fraction by the same number and not change the fraction. We get what is called an equivalent fraction. Something it's an equivalent, the same amount, but it looks a lot different. Well, what we're going to do is we're going to multiply both top and bottom by 1 plus cosine of x. Okay, so if we multiply top and bottom by 1 plus cosine x, what we are left with, if we FOIL this out, we have 1, this is binomials, minus cosine of x plus cosine of x minus cosine squared of x. So if we FOIL this out, we have a minus cosine x plus cosine x, which these cancel out. So what we're left with is 1 minus cosine squared of x. On the bottom, we're left with 1 plus cosine times 1 plus cosine. So we have 1 plus cosine of x quantity squared. Now, thinking back to day 1 when we dealt with some trig identities, 1 minus cosine squared is equal to something else. What was that? That's correct, it is the sine squared. So this is equal to the square root of sine squared of x over 1 plus cosine squared of x. Well, I'm taking square root of two things that are being squared. If I'm taking the square root of two things that are being squared, they go bye-bye. So the tangent of half x can equal the sine of x over 1 plus the cosine of x. And once again, that's on the formula sheet. Once again, if I would multiply top and bottom by 1 minus cosine of x, what we will come up with is tangent of x over 2 is going to equal 1 minus cosine of x over the sine of x. Typically, we have three formulas here. What I tend to use the most is this one right here. Reason why is if I have some sort of radical I could deal with, it's easier to rationalize the denominator because I have a radical in there. Here we have the cosine of theta is equal to negative 3/5. Theta is between 90 and 180 degrees. I want to find the sine, cosine, and tangent of my angle here. Well, let's get a picture. If I'm between 90 and 180 degrees, I'm in quadrant number 2, which I have a picture of here. The cosine of this angle is negative 3 over 5. Just for giggles, I'm going to throw the 4 in there. We want to find the sine of theta over 2. Well, from the front side, this is defined just as plus or minus square root of 1 minus cosine of theta divided by 2. Well, if I look at the cosine of theta, that's negative 3 over 5. So we have plus or minus square root of 1 minus a negative 3 over 5 over 2. Now we have minus a negative, so these will cancel out to plus. And what you can do, if you want, is quantify the top, 1 plus 3/5, and divide it by 2. So if we quantify the top, and just clickety-clack out, quantity 1 plus 3 divided by 5, and quantity, divide by 2, hit my math button, hit enter, it takes me back to the fraction of 4/5. So we have plus or minus square root of 4 over 5. Now we have to simplify this, so now we have to go back to our algebraic skills. Algebraic skills, this is square root of 4 over square root of 5. And we're still plus or minus, which is plus or minus 2 over square root of 5. But then we have to rationalize this by multiplying top and bottom by square root of 5. So we have plus or minus 2 square root of 5 over 5. Once again, please do rationalize these. Now the question is, I have a plus and I have a minus. Which one do I utilize? Well, if theta is between 90 and 180 degrees, what is half theta in between? Ooh, that's a thinker. If theta is between 90 and 180, what's half theta in between? Well, we can divide this by 2, this by 2. This gives me 45 and 90 degrees. So my half theta is between 0 or 45 and 90 degrees. What I suggest you do is pick any number between 90 and 180 and take the sine of that value. Say, let's see here. Oh, let's go 64. Sine of 64. All I'm looking to see, do I have a positive there or do I have a negative there? Well, we got a positive there, so my solution is going to be a positive 2 square root of 5 over 5. And that's the last thing you have to be able to check with this. If we take the cosine, now we did the cosine here. The cosine is going to follow the same way in the same method of madness. Cosine of theta over 2, half theta, is plus or minus square root of 1 plus cosine of theta divided by 2. Okay, what I want you to do is I'm going to want you to work this one by yourself. Okay, I want you to work it by yourself. Follow the same pattern we just did up here. So go ahead and turn the video off, work the problem out, turn it back on, and I'll be going through the solution for you. So go ahead, turn it off, and follow the same thing that we just did there, and then turn it back on and check your solution. Well, the cosine of theta, once again, is negative 3 over 5. So we have plus or minus square root of 1 plus a negative 3 over 5 divided by 2. Once again, we can clickety-clack through our calculator. Parenthesis 1 minus 3 divided by 5 divided by 2. Hit your math button, hit enter. We get the value of 1/5. So we have plus or minus square root of 1 over 5, which is 1 over square root of 5. And then rationalizing top and bottom, we multiply by radical 5. So we have plus or minus square root of 5 over 5. Once again, we have to determine, is it a positive or negative? We could take the cosine of any angle, once again, between 0 and 40, or 45 and 90, and we will come down to a positive square root of 5 over 5. Now the tangent half theta, once again, you can use any of the formulas that you want up above. I suggest you use the last one here. 1 minus cosine theta over sine of theta. It'll make us use the cosine, that's fine. So we have, and I don't have to worry about radicals, which is nice. So we have 1 minus a negative 3 over 5 divided by 4 over 5. The nice thing about this is your positives and negatives at the very end will come out for you. Once again, we have minus a negative, so these go away. Now you need to watch what you do. We have a quantity of 1 plus 3 divided by 5, divided by quantity 4 divided by 5. Hit your math button, hit enter, and it gives us a value of dose. I don't have to worry about checking is it positive or is it negative. I just have to get my solution down there. This is half angles. Tomorrow we'll deal with sums and products formulas and work a little bit of sums and products, and that will be the last of the material that we will cover. Look for a review day Thursday, quiz on Friday, very similar to what we did last week in regards to our angles and working with the angles. So this will be the half angle formulas. I will have some extra problems for you to work on. So go ahead and complete the extra problems to work on them. That's your homework assignment. Other than that, I'm done for the day. This is all the material we have to cover for today. I miss you guys. I wish we were back in classroom. Some of you I saw last night in the drive-bys. It was great to see you. It picked up my spirits also. It's a struggle time, but being able to see people and just waving at people and talking to people in their cars, it made me very happy. It was a good thing last night. So hopefully it went well for you if you did show up and drive through last night. But it was a good thing. But once again, please stay safe. Keep your social distancing. Let's get us back to as normal as possible as quickly as possible. Other than that, adios. I'm out of here. You folks have a great day.